This chapter will focus on how to diagnose faulty refrigeration cycle. The first section of this chapter is how to diagnose a faulty three-way valve, and the second is how to diagnose a clogged capillary tube. 1. How to diagnose a faulty three-way valve. First, let's learn about the role of a three-way valve. The refrigerant that passes through the unit dryer flows into the evaporator through the left or right path or both outlets of the three-way valve. Consequently, the role of the three-way valve is to switch the directional flow of the refrigerant. Second, let's look at the interconnection writing diagram and pin map of the three-way valve. Three-way valve is available in two types, Saginomiya valve and SCD valve. The coil resistance of Saginomiya valve is measured at 44 ohm, and pin number 3 and 4 are not connected. The coil resistance of SCD valve is measured at 38 ohm, and the resistance between pin number 3 and 4 is 0 ohm. If you look at the faulty SCD valve case, there is an open circuit between the pin number 3 and number 4. In this case, SCD fails to work properly and results in poor cooling. Third, let's look at the types of the three-way valve. There are two types of the valve, SCD, Korean brand valve, and Saginomiya, Japanese brand valve. Operation voltage, DC 12 volts. Operation principle. A three-way valve is operated by the pulse voltage of the main PCB. It is not possible to alternate between Saginomiya and SCD valve. It can cause freezing defects from malfunction. Fourth, let's look at the flow control of the Saginomiya valve. As the electricity flows through the three-way valve coil, the disc beneath the circular rotor magnet rotates and changes the flow of the refrigerant. Let me explain the reset function of Saginomiya valve. The reset changes the position of the three-way valve back into its initial position. It begins from the position where it is not possible to move further as it is stuck in a protrusion while rotating clockwise. If it is initialized, both outlets of the three-way valve will open. If you look at the right image, the internal structure of Saginomiya valve consists of one inlet and two outlets. The left outlet directs refrigerant flow towards the freezer, and the right outlet directs the flow to the fridge. For opening left or right side or closing, it moves to a certain step towards left or right side. Fifth, let's look at the flow control of the SCD valve. The central gear at the bottom of the rotor magnet rotates with the disc gear, changing the flow of the refrigerant. Let me explain the reset function of the SCD three-way valve. It begins from the position where it is not possible to move further as it is stuck in a protrusion while rotating clockwise. If it is initialized, the right-hand side of the three-way valve will slightly open and will not open the both ends. 6. Let's look at the motions of the three-way valve. Saginomiya valve rotates 36 steps in total to go back to its initial position, and both outlets will open. If the valve rotates 8 steps counterclockwise from its initial position, the left outlet will open. If the valve rotates 20 steps counterclockwise, both outlets will close. If the valve rotates 28 steps from the initial position, the right outlet will open. SCD valve rotates 120 steps in total to return to its initial position, but both outlets on each side are almost closed. If the valve rotates 16 steps counterclockwise from its initial position, both outlets will close. If the valve rotates 56 steps counterclockwise, the left outlet will open. If the valve rotates 76 steps from its initial position, both outlets will open. And if it rotates 100 steps, the right outlet will open. 7th, let's look at how to use three-way valve jig. The three-way valve jig is a device developed by Korea Service Academy and validated by Refrigerator Business Unit, and can be used to move the valve to the desired direction and for inspecting valve defects and cooling power. Now, let me explain how to use the jig briefly. First, connect a battery to the jig to turn it on. Second, connect the three-way valve cable to the jig. Third, remove the existing three-way valve connector and then connect the jig cable. Fourth, select one three-way on the jig. Fifth, select three-way valve type and then the direction. Once you divert the direction of refrigerant flow with the three-way valve using the jig, the diverted direction of flow will be maintained even after removing the jig cable. After the inspection, ensure to reconnect the three-way valve connector. 8th, let's look at how to check three-way valve using a jig. Required tools are three-way valve jig set and multi-tester. First, check the operational noises of a three-way valve. 1. Turn the product off to on. 2. The three-way valve in initial phase produces a bulky operational noise following parts initialization. If soft rotation sounds are produced, the signal is normal. 3. If irregular bulky sounds continue after the initialization, it indicates that three-way valve is restrained or PCV signal is defective. Second, measure the coil resistance of the three-way valve. If the coil has an open circuit, you will hear irregular operational noise or no noise at all. Third, connect the jig with a three-way valve. Connect the connector that is indicated as three-way on the side of jig and three-way valve with a cable. Fourth, select one three-way in the initial menu, and then select the three-way valve type. Fifth, check the matching direction of three-way valve towards either the freezer or fridge compartment. Normally, the left direction of three-way valve is the freezer, and the right direction is the fridge. For the side-by-side refrigerator, the left direction indicates the freezer, and the right direction indicates the fridge. Check the direction with the jig, as the direction can vary by model. 6. Open both ends of the three-way valve and check cooling power. The frost formation should occur in both evaporators. 7. Open the left side of three-way valve and check cooling power. Normally, cooling occurs in the freezer. The frost formation should occur only in the freezer evaporator. 8. Open the right side of three-way valve and check cooling power. Normally, cooling occurs in the fridge. The frost formation should occur only in the fridge evaporator. 9. Check cooling after closing all outlets of the three-way valve. The frost formation should not occur on the evaporators. How to diagnose a clogged capillary tube. First, let's look at the symptoms of capillary tube blockage. First symptom is the frost buildup on the upper area of the evaporator. As you can see in the image, there is a case of frost buildup on the upper area of evaporator. During the diagnosis, note that this is similar to a case of lack of gas. Second symptom is the frost buildup only covering the half of the evaporator, not the entire coils. In a case of complete blockage in the refrigeration cycle, the compressor's discharge area heats up and returns to slightly warm state. Let's learn about a clogged area in the refrigeration cycle. Usually, the most blocked area is the capillary tube. The inner diameter of a cap tube is less than 1 millimeter. As you can see in the image, the accumulation of foreign matter, moisture, and wax substances can clog the inside diameter of the cap tube. The first image on the bottom shows a case of wax accumulation clogging up the inside of the cap tube. The second image shows a side of cap tube clogged with foreign and fluorescent matter inside. The last image shows the actual foreign matter removed from the cap tube. Let me explain the principles of clogged capillary tube diagnosis. The right image shows the refrigeration cycle diagram of dual evaporator system in the freeze cycle. When the compressor starts working, the refrigerant flows through the condenser, dryer, and three-way valve and enters the evaporator from the cap tube to cool down. First, turn on the compressor for 10 minutes and measure the dryer pressure with a manifold gauge. If you turn off the refrigerator, the dryer pressure decreases. At this time, the pressure is slowly discharged from the dryer to cap tube through the three-way valve. If the dryer pressure won't drop, the diagnosis result is determined as clogged capillary tube. 4. Refrigeration cycle blockage diagnosis. Let's learn about diagnosing the cap tube blockage with a manifold gauge. Required tools are three-way valve jig set and manifold gauge. First, check the cooling condition of evaporator. Use the three-way valve jig to divert the refrigerant flow to either the freezer or fridge and check that the evaporator cools down. In a case of clogged cycle, frost builds up on the upper area of the evaporator. Second, control the three-way valve to verify the current of compressor in the freezer and fridge. When using the three-way valve to divert refrigerant flow to the freezer, the cycle is normal if the measured current of the compressor is normal and the freezer cools down. However, when using the three-way valve to divert refrigerant flow to the fridge, the cycle is determined to be clogged if the measured current of compressor is lower than the normal current and the freezer does not cool down. Third, check the pressure of the dryer while running the compressor. As the image shows, small flow meter gauge is recommended. This is to reduce the loss of refrigerant when removing the gauge. In a case of 0 psi or less, check for any blockage in a dryer inlet, compressor discharge area, and condenser outlet. Fourth, stop the compressor and check the decreasing speed of gas pressure. As the image shows, if the initial pressure of 200 psi drops to 30 psi after 5 minutes, the cycle is determined as normal. Fifth, if there is no change of pressure for 5 minutes after stopping the compressor, the cycle is determined as clogged. Sixth, when the evaporator cools down while heating the capillary tube, the tube is considered to be clogged. 5. How to diagnose clogged cycle with jig. Let's look at how to diagnose clogged cycle with three-way valve jig. Required tools are three-way valve jig set, digital pressure sensor, and vise pliers. First, connect the jig and three-way valve. Second, open the left outlet of the three-way valve. To test whether the freezer cap tube or the fridge cap tube have a blockage, first check the left side of the three-way valve for blockage. Third, connect the digital pressure sensor to jig. Press 3, press. In the jig menu to check the pressure. The pressure will indicate 0 psi. Fourth, connect the sensor to dryer and then measure the pressure. And then turn on the refrigerator and measure the pressure for 10 minutes. Fifth, after turning on the refrigerator for 10 minutes, check the pressure. If the pressure is 70 psi or higher, turn off the refrigerator and immediately press number 1 button on the jig. A cycle checking message will appear and cycle check will be automatically enabled for 30 seconds. At this time, the pressure under start indicates the initial pressure. The pressure under now indicates the decreasing pressure of dryer. The pressure under second shows reverse countdown starting from 30 to 0 and the decreased pressure. Therefore, you can check how much dryer pressure have decreased in 30 seconds through the jig, which helps to check if the cap tube is clogged or not. 6. Let's look at the expected result when the cycle is normal. The result on the right shows the pressure drop by 30 psi in 30 seconds, and a message saying over 10 psi is okay appears on the top. Normally, if the decreased pressure is 10 psi or higher, the refrigeration cycle can be considered as normal, free of blockage. Therefore, you can determine that the cycle is normal as the dryer pressure dropped by 10 psi or more after passing through the cap tube. 7. Let's look at the expected result when the cap tube is clogged. The result on the right shows the pressure dropped by 1 psi in 30 seconds, and a cycle blocked message appears on the top. Normally, if the pressure drops by 4 psi or less, the cycle can be considered as clogged. Therefore, as the result shows, you can determine that the left cap tube of the three-way valve is clogged as the dryer pressure dropped by 4 psi or less after passing through the cap tube. 8. Let's proceed to the blockage diagnosis of the right cap tube of three-way valve. The diagnosis method is same as the blockage diagnosis of the left cap tube. First, open the right outlet of the three-way valve. 9. Connect the sensor to dryer and measure the pressure, and then turn on the refrigerator and measure the pressure for 10 minutes. 10th. Turn on the refrigerator for 10 minutes and check the pressure. If the pressure is 70 psi or higher, turn off the unit and immediately press number 1 button on the jig. A cycle checking message will appear and cycle check will be automatically enabled for 30 seconds. 11th. The result on the right shows that the pressure dropped by 30 psi in 30 seconds. As the pressure have dropped more than 10 psi, the cycle can be considered as normal. 12th. The result on the right shows that the pressure dropped by 1 psi in 30 seconds. As the pressure have dropped by less than 4 psi, you can determine that the right cap tube of the three-way valve is clogged. In this chapter, we will learn about how to diagnose gas leakage. The sections of this chapter are as follows. 1. Gas leak detector equipment. 2. How to measure equilibrium pressure. 3. How to diagnose evaporators gas leaks. 4. How to diagnose condensers gas leaks. 5. How to diagnose hot lines gas leaks. 1. Gas leak detector equipment. First, let's learn about the gas leak detector. Let me explain the product information of model 69337 Yellow Jacket and how to use it. This product can detect all types of refrigerants including CFC, HCFC, HFC, as well as non-flammable refrigerants including R-11, R-22, and etc. The LED number indicator for leakage level is from 1 to 9. Now let's move on to how to use the gas leak detector. 1. Press the power switch to turn on the detector power. After 10 to 30 seconds, the heating lamp on the sensor lights up and the unit enters the leak detecting standby mode while beeping loudly. 2. The detector sensitivity is divided into 3 levels, low, normal, and high, and can be adjusted by the sensitivity button. 3. Slowly move the detector over the possible leaking area for detection. 4. Because refrigerants are heavier than air, it is more effective to hold the detector right below the possible leaking area. 5. Normally, the detector indicates 3 or higher numbers over the refrigerant leaking area. Precaution: please do not apply refrigerant directly around the sensor for testing. How to check for gas leaks with a leak detector. Required tools are manifold gauge, R22 or R410A, and leak detector. 1. Turn on the gas leak detector where there is no gas contamination and wait for 30 seconds to warm up. 2. Check the sensor sensitivity of leak test standard bottle when the detector is ready. Replace the sensor with a new one if no detection is found. 3. Slowly move the detector over the possible leaking area for measurement. Here is the inspecting order of complete gas leaks in the refrigerator. First, inject the gas into suction or high pressure area. 2. Wait for 30 seconds after turning on the detector. 3. Move the sensor slowly around the leaking spot. Precaution: 1. In a case of total gas leakage, inject gas before using the detector. Degrees of pressure per injection gas is as follows. For R22, the pressure is 150 psi. For R410A, the pressure is 200 psi. R410A has an advantage of higher pressure than R22. 2. Turn off the fan motor and conduct a test during machine room inspection. 3. Do not use the detector over the molten restrainer, rubber pad, on the evaporator surface, because it reacts to the molten area. Keep this in mind when checking for evaporator leaks to determine whether to use the leak detector or not. 4. Make sure to check with the detector before applying the detection solution, as the solution reacts to the detector. Now let's learn about nitrogen and leak detection solution. Required tools are nitrogen, manifold gauge, and refrigerant leak detection solution. How to connect nitrogen. Connect the red hose of manifold gauge to dryer. Connect the yellow hose of manifold gauge to refrigerant tank. Do not use the blue hose. Caution: using the blue hose will damage the low pressure gauge. How to adjust nitrogen output pressure. In this image, there is a main valve on the right. Turn the valve counterclockwise to open the nitrogen tank. There are 2 gauges on the middle. On the right is the tank pressure gauge. The left is the nitrogen output gauge. If you open the main valve, the pressure will be displayed on the tank pressure gauge. The output valve can be used to control the nitrogen pressure. Turn the valve clockwise to increase the output pressure of nitrogen. Let me explain how to adjust the pressure. First, open the main valve and verify that the pressure is at least 20 kgf per centimeter square, or 280 psi, which is appropriate for checking leaks. Second, open the output valve and adjust the pressure to 10 to 20 kgf per centimeter square, or 150 to 280 psi. Third, open the manifold gauge high pressure valve to charge nitrogen into the refrigerator. Take note that the evaporator can explode due to high pressure nitrogen in response to sudden opening of the valve. Proper pressure is 10 to 20 kgf per centimeter square, or 150 to 280 psi. How to check for gas leaks by different area. Apply leak detection solution to the pipe connection area. Check for leaks on the rear side of the pipe connection with a mirror. If there is a gas leak, perform rework. Let's learn about the UV lamp and UV dryer. Required tools are UV lamp and UV dryer. Recommended wavelength of UV lamp is 395 nanometers. UV dryer is developed to detect refrigerant leaking spots more easily as fluorescent material is injected into UV dryer and circulates in the refrigeration cycle to find the leaks. How to use. Wait several days after installing the UV dryer. 2. Illuminate the UV lamp to detect the leaking spot beaming with fluorescent material. 3. Verify the leaks in a dark place. The leaking area will glow with fluorescent material as seen in the bottom right image. 2. How to measure equilibrium pressure. Let's look at how to measure the equilibrium pressure when refrigerator is turned off in order to determine gas leaks. Required tools are clamp meter, UV lamp, 3-way valve jig set, digital pressure sensor, mini hose, and pinch pliers. First, measure the electric current. Normally, it shows low current if there is a leakage. 2. Check for frost buildup on the evaporator and check for leaks or oil traces. Frost normally builds up on top of the evaporator if leaks occur, and leaks are detected if fluorescent materials are found using a UV lamp. 3. Open both ends of the 3-way valve with the jig. 4. Remove power and completely remove frost on evaporator. If the frost on 2 evaporators is not removed, the pressure will read 50% of the normal pressure. 5. Connect the sensor to dryer and then measure the pressure. Turn off the compressor and measure equilibrium pressure for 10 minutes. 6. Compare the measured equilibrium pressure with normal equilibrium pressure. Normal equilibrium pressure of the ambient temperature at 20 to 25 degrees Celsius or 60 to 77 degrees Fahrenheit is as follows. For R600A, the equilibrium pressure is 20 to 25 psi or 1.4 to 1.7 kgf. For R134A, the equilibrium pressure is 45 to 50 psi or 3.1 to 3.5 kgf. Normally, 10 psi or lower is diagnosed as gas leakage. The values mentioned above are served only as references since they can vary depending on product capacity. Now let's move on to how to diagnose evaporator's gas leaks. First, let's look at the evaporator leaking spots. Number 1 is a case of leakage from the corroded copper pipe and aluminum pipe at the top of the evaporator. Number 2 is a leakage from the aluminum pipe at the evaporator inlet. As the right image shows, when a leak is found after conducting a leak test on the leaking area, bubbles are formed. As the close-up image shows, gas leaks are normally found in a small corroded hole. Number 3 is a leakage in argon-welded part of the accumulator. If you look at the left image of the accumulator, bubbles are formed on the upper and lower section of the argon-welded area. Number 4 is a leakage in molten metal side of the evaporator. Number 5 is a leakage found in the aluminum pipe of the molten restrainer at the bottom of the evaporator. In order to efficiently find the evaporator gas leaks, you need to quickly find a corroded hole on the discolored area of the evaporator. The most frequently used method is to inject nitrogen into the evaporator to apply soap water to find the leaking spot. Now let's learn about the evaporator gas leakage check process. The required tools are UV lamp, three-way valve jig set, pinch pliers, nitrogen or R410A, manifold gauge, leak detector, and leak detection solution. First, check leaking spots directly and check the UV lamp. 2. Check the residual amount of gas first before injecting gas. R22 and R410A or nitrogen. Inject as gas state into the refrigerator. The maximum injection pressure is 280 psi or 20 kgf. Normally, it is recommended to inject the gas to the charging tube of compressor. To inject the gas into the dryer, open both outlets of the three-way valve and then inject the gas. Wait for 5 minutes and then you can conduct the leak test. 3. Check with gas leak detector. Slowly move the gas leak detector from the area number 1 to number 5. Caution: you're not allowed to apply leak detection solution before using the detector. 4. Apply leak detection solution from area number 1 to number 5. Caution: do not use leak detector after applying the detection solution. Precautions for leakage inspection. 1. The leak detecting order starts by using the leak detector first and then followed by the soapy water test. 2. Make final judgment based on soapy water test. Attach the image of soap bubbles to the results. 3. Make sure to test sensor with leak test bottle before using the leak detector. In case of a model with 2 evaporators, check leakage after disassembling the whole unit.